Hey, everybody, and welcome to another episode of Software Defined Everything, the podcast for smart world systems. I'm your host, Steven Onzo, and today I'm thrilled to welcome our next guest. He's the lead vehicle software engineer at REGENT Craft, which is, without a doubt, one of our coolest customers. REGENT Craft is transforming coastal transportation with their electric seagliders that glide seamlessly across the coast, redefining what's possible in sustainable coastal travel. And with that, I'm excited to introduce Evan Orenstein, lead vehicle software engineer at REGENT Craft. Evan, welcome to the podcast.
Thanks for having me. We're happy to be here.
I have to mention, first off, for our listeners or for our viewers who are watching the podcast on video, looks like you're in a simulation room. Can you explain what this is just a little bit further?
Yeah, so I'm here at our headquarters in Rhode Island in one of our simulation rooms we have. We use this for operational training for our captains and also as an engineering simulation to iterate on software and make sure we're ready to go out on the water.
Well, let's start things off by talking about seagliders. What inspired REGENT Craft to pursue the concept of all-electric wing and ground effect vehicles, and how do you see it revolutionizing coastal travel?
Yeah, so we saw essentially a huge untapped market opportunity, and really the vision was to revolutionize maritime mobility. Really we're looking to drastically reduce the time and cost of transporting people and the goods between really coastal destinations and in communities.
The seagliders at REGENT are 100% electric and zero emission. Could you talk about how important sustainability is to REGENT's mission and how it affects the future of coastal transportation?
Yeah, so, seagliders are all electric, battery powered, right? So zero emissions. We're really looking to be part of creating a multimodal, sustainable transportation future, right? There's a big push in industry for this in both aviation and in maritime. And as someone who's kind of in between those two worlds, trying to build something to connect people, sustainability is important, and the businesses must be sustainable, but also those sustainable solutions have to make business sense, and seagliders are both.
Your seagliders operate at the intersection of air and sea travel. They're not boats and they're not quite planes. What are some of the challenges you've had to face in designing a vehicle that combines both of these domains? And how has the use of software helped you overcome those challenges?
Yeah, so one of the key challenges we have is sensor systems tend to be built for either typically air or sea, right? They're two very different environments, and software for us really enables having distributed systems with multimodal sensors that allow us to really understand what's going on both in the maritime and in the air, in both those worlds. And I'd say also that transition from water to air is very challenging for us. So there's a lot of work being done and really understanding the nonlinearities and the complexity of that transition for our vehicle, and software is really at the root of all of that work.
Speaking of software, I would be remiss not to mention how RTI Connext plays an important role in REGENT Craft's software systems. Can you explain how your partnership with RTI has helped solve some of the really technical challenges in developing seagliders?
Yeah, so I'd say the first thing that comes to mind when using RTI as a product here at Regent, it's data, right? So we produce, as you can imagine, a lot of data, terabytes upon terabytes of data on a regular basis. So being able to really analyze that, but also pull that out of the systems that are running in our vehicle. So really RTI and using DDS as a software middleware has enabled us to take different systems that have been developed and take data from essentially our control system all the way out to a support boat, to a control room, right, to enable the rapid processing, both in real time and in post time, understanding of what's going on, right? What's the vehicle doing and why? So RTI is really at the core of our data-centric approach to developing the seaglider.
Touching on that a little bit more, given the high speed and low altitude nature of the seagliders, how critical is real-time data processing for safety and efficiency? And what role does RTI play in ensuring that safety and efficiency is carried out smoothly.
Yeah, real-time data is extremely critical, right? We run several real-time systems on the vehicle, and really where kind of RTI plays a role for us is in being able to pull that data off board and assess it in real time. So, in operations, having our team of engineers who aren't able to be on the vehicle, looking at live data, understanding what's going on, being able to communicate and signal to our captains to give them more information about how our system's performing in real time is really, really critical to us, as well as doing analysis right after tests or as part of development to understand where latencies, where are areas where we could make improvements and how our system's running, and places that you may have discrepancies or misunderstandings between systems.
Can you talk a little bit how a distributed system software like RTI Connext could help not only with the final product of a seaglider, but the simulation and the testing before?
Yeah, so behind us, right, we have some visualization done. It's actually all done in Unreal Engine here at Regent, and that's actually using a live data stream of using RTI right now, right? So in its simplest form, we're able to use it to even connect our image generator that we've built and make sure we can visualize what's going on with the seaglider and understand, is the control system doing what we expect visually, which is really a useful thing for us. And then in general, I'd say the kind of plug and play capability of that publisher subscriber architecture that RTI DDS provides for us is really, really useful for accelerating development across teams. So you can define an interface between systems, which effectively is between software teams. We can go off and develop software that generates and emulates that data. And then we can iterate really, really fast on improving things like a human machine interface, that, an operator seeing, what makes sense, what color should something be, how big should an icon be that's moving around on the screen. All of those things can really be iterated on, but as opposed to doing it with, some sort of a fake data generation, we can actually use the interfaces that will exist on the vehicle. So while you're developing, you're also testing and improving upon, the thing that will inevitably be running on the vehicle.
So it's safe to say that these simulations are meant to be as close to the real thing as possible. That way there's no surprises or anything when you go to market.
Yeah, 100%. And even the simplest thing of I'm running a simulation here behind me, and I could have an engineer at their desk in the other room with their own tool analyzing and understanding what's going on here, right? Allows me to distribute that data even across our local network here, which is really powerful.
One of the promises of REGENT Craft is cost-effective regional transport, which I'm sure everyone is very excited to hear. How does software automation help reduce operational costs for seagliders, and what does that mean for your customers?
Yeah, so I'd say, first and foremost, it's in, reducing the bottom line for how much one of these costs, right? So that's in development. That's, how can we iterate faster? How can we close the loop as engineers in such a way that we're being cost effective as a business, and in turn, those savings are passed on to customers in use of the product. So, kind of leveraging what we were talking about with this last question, right? Being able to distribute and really accelerate teams in parallel allows us to do things on a shorter timeline in a more cost-effective manner. And I'd say, thinking past that, right, in operation, all the data, right? This data-centric approach is going to be really, really important, right? So understanding the ins and outs of our vehicle and having a good representation of what is nominal, right? What's normal operation of the vehicle. So you can think of a lot of what we're doing now and in the future is setting that baseline performance, what this looks like. And, data is king in the world today and in software, and we'll be able to use all that data that we're generating from the vehicle to then do analysis in both real time for things like predictive analysis, as well as post-processing to understand if something's aging, if something's occurring, so we can get to a problem faster. We can make, adjustments sooner and then reduce costs in operation.
You mentioned the word data-centric. Can you talk a little bit about how important data centricity is to a large distributed system and how it makes it more efficient?
Yeah, I'd say one of the key kind of unlocks there is being able to localize hardware together, right? So I can have distributed compute or essentially machines in, for instance, like the tail of a vehicle that's communicating with other computers, in the cockpit or something, right? So this is something that having that distributed system allows us to use higher throughput means of data communication that aren't able to travel those longer distances, right? So the key kind of unlock there is taking those large amounts of data as close to their source as possible, processing them into information, and only sending that information over those kind of longer distances that may take, slower relative speeds. And that's where, for us, RTI is a part of that ecosystem on the vehicle to help transport that data.
Piggybacking on your response there a little bit, how does real-time technology enable scalability in engineering teams and products?
Yeah, so I'd say really it's about speaking the same language, right? So, one of the key things we've done here at Regent from day one, I was in the early 20s as far as the number of employee. I've been here for almost 3 years now, and one of the things I really pushed on was having common tools, common processes, right? So you want to have the most flexibility in where you can apply engineering resources to go and solve problems. And in that, using, RTI DDS for this communication backbone for a couple of our systems and in simulation, it allows us to kind of reuse and build upon that knowledge base as a team and grow that over time. So it gives us really a lot of flexibility to scale systems, but also to really manage teams and be more dynamic. As a startup, that's really critical when we have smaller team. Everyone's really trying to be effective and efficient in our work, and something comes up, we need an engineer to go step in to solve a problem. Having that common means of communication between software systems is critical and kind of a smooth transition there.
That's actually a good segue as we wind down the conversation here. I have one last question, but as a forward-thinking, software-driven company, what advice would you give to another tech-driven startup trying to innovate in the transportation space?
Yeah, I'd say, bottom line is hire the right people, right? So that's always the challenge and the where you're going to see the most benefit. You're a startup, you have limited resources, limited time, so you really need to make sure you have the right engineers in place to go get the job done and solve hard problems. And, one of the things that's really exciting working here at Regent is we're solving problems that haven't been solved before, right? We're doing new things that it's not something I can just go read a paper on and understand, or go talk to someone who's been around for 10 years and learn something from them, right? We're blazing a trail, and, having engineers who aren't afraid to be a part of that and really iterate and fail fast is really important. And then I think the other thing I'd say, piggybacking on kind of my response earlier, is having common tools, common environments that teams work in is going to be really, really useful in allowing that kind of that dynamic approach to engineers who wear multiple hats.
Well, that wraps up all of the questions that I had for today. Evan, would you like to let our listeners know where they could find out a little bit more about REGENT Craft?
Yeah, I'd say go to our website, regentcraft.com. We're also on pretty much every major social media app as well. Definitely follow us. We have a really big year coming up in sea trials out on the water of our full-scale prototype, and there's a lot to look forward to here in 2025, and we're really gearing up to make a big impact and change transportation for the better.
Evan, thank you so much for joining us today and explaining the incredible work that you guys are doing over at REGENT Craft. It's been a pleasure talking with you today.
Thank you very much.